So what we're staring at right now is the 2018 free response questions. The first 2 questions have a calculator active. So what do you want to do? Do you want to have time to think about it? Do we want to just brainstorm together? What's going to help you the most? And you have a calculator for questions 2 and 1. Brody, I feel like you're always good at the words. You're good with the using correct units, interpret the meaning. So you guys, g prime of 3 here, since they didn't give us a function, we had to do change in y over change in x around the 3. Feel okay with that? Could you leave it right here? Yeah, dude. Could totally leave it there. Now, granted, when you write it in the context of the question, it makes a little bit more sense. Did you guys simplify that to get 1.35? Awesome. So how would I explain g prime of 3? Grain is being added to a silo. The rate at which the grain is being added is this g of t, and that's cubic feet per minute. So if they want g prime of 3, it's like a rate of a rate, right? It's a rate of a rate. How might we describe that? There's a couple musts. Exactly. He's saying, okay, I've got to take the rate of this rate. So it's always going to be that cubic feet, and then we're going to say per minute, or per minute squared. So what we also have to mention is that 3. So I'd say at t equals 3. That's necessary because it's not always going to be at 3. They just want it at that moment. I would say the rate the grain is being added to the silo. Would we say is increasing or decreasing if this was positive? Increasing. Good. They want to see that word increasing at a, I'm going to say rate of, which sounds so silly, but we've got to say the rate of a rate. 1.35, like you said, Mr. Brody, cubic feet. So I'm going to put feet cubed per minute squared, or cubic feet per minute per minute. What I want you to take from that is g prime means that we've got to take the rate of a rate. I've got to say if I'm doing a cubic feet per minute, don't forget you could see that from change in y over change in x, cubic feet per minute. And we got to specify at that time t equals 3. You guys, that'd be 2 points. We're at a 22%. If we go get one more point on parts B, C, or D, then we've got a 3. Okay? Let's go try B. B says, write an integral expression that represents the total amount of grain added to the silo from t equals 0 to 8. Let's just start with that. Write an integral expression that represents the total amount of grain added to the silo from 0 to 8. If I go back to my words, the rate at which grain is being added is g of t. That's what I take from that beginning. The rate at which it's being added. Don't overthink it. Anyone have an integral to represent that? Baxter, what are you thinking?
The integral from 0 to 8 of g.
That's it. If you remember the dt or don't remember the dt, that's fine. That's all you got to write, Mr. Brody.
Do you not need
Oh, absolute value?
Yeah.
Good call. Unless they said, the total amount. I see what you're saying. Total amount of grain. Okay. So, they don't have absolute value on their answer key. And why wouldn't they?
Do you think the answer is different?
Would the answer be different? So all of these are already positive. Maybe that's why they didn't have them. Let me see real fast, though, on their scoring guidelines. They didn't put absolute value. And to your point, so it would still be right because we're still going to have the same answer because these y values are still positive. You saw that word total, didn't you? I think you're safe either way. It's a really good point.
But from 5 to 6, it decreases that way.
Yeah, right? Good point. From 5 to 6, she's saying that y value goes down.
It's still increasing, just less.
Right. So Again, you could have absolute value because you saw total, and it's not going to hurt because the data they gave us was already positive. If they asked for total and it was not already positive, I think we'd need our absolute value bars. It's a good call. We see total, we see absolute value. Good observation. So you guys just got a point from that. You just got a point. Now it says, use a right Riemann sum with 4 subintervals to approximate that integral. When we see this integral here, this is saying find the area under the curve. And if you want me to sketch a little picture, I can. So if we've got 0, 12.8, I'm going to just put this in a picture form for you. And then we got, I'm going to really spread this out, 1, 15.1, 5, 20.5, whoops, 5, come here, buddy, whoop, okay, 5, 20.5, and then 6, 18.3, and then 8, 22.7. Okay, so my function might look something like this. Woo! I'm gonna get rid of this up here. And it says use a right Riemann sum. So that says estimate the area of the curve. So in a Riemann sum, you guys, that's finding the area of a rectangle where the right side hits the function. So a right Riemann sum would look like this. Boom, 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 boom. And then it's right side over down, right side over down, right side over down. How would I find the area of this first rectangle? What's its base? Yeah, to go from 0 to 1, my base is going to be 1. What would the right height be? Is it going to be 12.8 or 15.1? Yeah, in a right Riemann sum, you do not use the left height. So we're going to say 1 times 15.1. What's my next base? Say that again, Brod. 4 times its height. 20.5. You go ahead and finish your Riemann sum. Guys, can we leave it there? Yeah, don't waste the time. If we did add it up, I got 160.8. Now, on this question, they did not ask this for a reason. They didn't say, would this be an overestimate or underestimate? Because my function is decreasing, like Baxter pointed out. Let's say my function was like this, though. Let's say my function was like that, and we used a right Riemann sum. Over or underestimate? Overestimate because... yeah, G of t is increasing. That's what you got to say there. Let's say that we had a decreasing function. And again, the whole thing has to be decreasing. If I did decreasing instead, a right Riemann sum is now an underestimate because G of t is decreasing. Sound good? They didn't ask that because our function's doing both. That's 3 points. They'd give you 1 point for the integral, 2 points for this. This one, if you got one number wrong, they're still going to give you all 2 points. This is called the 7/8 rule. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 pieces of data. If you get 7 of the 8 right, they give you all the points. Say that again? Yep, for the writing the integral. 1 point for that, and then 2 points for this. Yep. Great question. Do we need units? Since they didn't say indicate units of measure, we do not. Let's talk about what would those units be, though. It would just be that we're taking, again, don't forget, we're taking base times height. This distance times this distance, cubic feet per minute times minute. Let's think about that. Cubic feet per minute times minutes. Exactly. It's going to just be, my minutes are going to cancel, and I just have cubic feet. And does that make sense? That's the amount of grain added to the silo, because that's going to be a 3D shape. That's that volume of grain. And D. Now I want to give you guys time. So if you can get those points, you're at a 1, 2, 3, 4, 5. You're already at a 4 you're at a 4 on the AP test, just doing A and B. So to get that 5, parts C and D might be a little harder. Let's see. I want to give you a sec to try C on your own. Good call.
For G of T, right?
For G of T, correct. We only have that table. And the amount from part B was 160.8. When it says use your result from part B, if you didn't type that in, it was 160.8 cubic feet. I did get an answer of 61.749. How the heck do we get that? It says the grain is spoiling at the rate of W of T, and that's a rate. Use the result from part B to approximate the amount of unspoiled. So what do we have to do? We had this much grain being put into the silo, and then the spoiling, do we want to add that to it or subtract it? I want to subtract what's being spoiled. How do I find out how much is being spoiled if they gave me the rate of it being spoiled? Integrate or derivative of that rate? Yeah, the integral of that rate is going to tell me how much is spoiled. Integrate of a rate is going to say, ooh, this much spoiled, and I need to subtract that. So when I typed this into my calculator, that's when I got 61.749. What kind of questions do we have on that setup? Like,
Do you have to, can you just leave your answer as a number, do you have to do a sentence?
or do we have to do a what? Oh, a sentence. Good call. Nope. Since they just said approximate the amount, just a number is fine. It's only when they say justify your answer, give context, things like that, that we need a sentence.
Do you need the,
Units?
yeah.
Good call. Did they ask for them? They did not. Good question. But if they're asking about, hey, how much grain is unspoiled? Again, we still have those cubic feet, but we do not need it unless they ask for it. Great questions, Brode. That's 2 points. So now we're at 7 out of 9 points. Feeling good. Now this is really separating the 4s from the 5s. Told, you want me to go over anything from that one?
No, I'm good.
Okay. Tristo?
I'm all good.
Okay. Based on part C, now also give yourself credit. If you got the wrong answer in part C, but do part D correctly with your wrong answer, they'll give you 100%. Okay. It says, based on the model in C, is the amount of unspoiled grain increasing or decreasing at T equals 6? Show the work that leads to your answer. This to me is a very hard part. Based on the model in part C, so using that W, is the amount of unspoiled grain increasing or decreasing at T equals 6? Okay, so they gave us rates, right? All they gave us were rates. This W of T is a rate, and the table was also the rate. If I go back to the previous page, the table G of T is the rate that that grain is coming in cubic feet per minute. So if I want to know if the amount of unspoiled grain is increasing or decreasing, what would happen if I compare the rate that the grain is coming in at 6 hours, 6 minutes, 6 minutes versus the rate that the grain is spoiling at 6 minutes? How would we be able to compare those to figure out if that amount is increasing or decreasing?
If G of 6 is more than a positive.
Exactly. If the rate that is being added in is bigger than the rate that it's spoiling, then that amount is going to increase, right? So let's go try to find G of 6. Now, if we flip back, do we know what G of 6 is from my table? Because that's a table of G. What'd they say for G of 6? Yeah. G of 6 is 18.3. How would we find W of 6? Yeah, because this is just W of T. So we're going to use our calculator and go find W of 6. So I'm going to plug in a 32 times root sine of pi times 6 over 74. Okay. Did y'all get a 2.237 when you plugged in that 6? So how are we going to say if the rate that is coming in, how are we going to say that? Because this one does say show your work, and then is the amount of unspoiled increasing or decreasing. So they do want some words here. What do you think? How could we describe that? Because, yeah, we could just say because g of 6 is greater than w of 6. Or some people might say because g of 6 minus w of 6 is greater than 0, meaning it's positive, however you want to say it. Because g of 6 is greater than w of 6, let's answer that question. I'd say the amount of unspoiled grain.
Is that 2.237 W of 6 or the total? That's the.
Oh, snap. Good call. What was w of 6? This is the difference.
Okay.
Sorry, what was w of 6? 15 point...
It was
16.063. Whew, thank you. When I subtracted them, I went this route. So 18.3 minus that got me something still positive. Thank you for that, Brode. Again, g of 6 is still greater than the amount, therefore the amount of unspoiled grain in the silo is increasing. There's one really important thing that we need to add. Where are we looking at this? Exactly, at t equals 6. Because that's not always going to be the case. It depends on the time that we look. So they want us to be specific with that.
Are you allowed to like put B/C and like?
Yes, because, yep. AMT for amount, yep. They're good with it. Okay. Let's do one more and then get yourself a donut. I definitely want you guys to try this one, the snail on your own for sure. Part A, go get yourself 1 point. Actually, and do part B as well. So on these two, again, you guys don't overthink things, right? They gave us the velocity. And when I go through, I do like to highlight, like you're saying, Brode, shoot, they gave us the velocity. And I know you won't have a highlighter, but underline things. They gave us the velocity, boom. They want acceleration, so I'm going to do math 8 when x is 5. And you do not need this lingo. You can literally put the answer for this one. That is 1 point. They know you're going to type that in your calculator, okay? You okay with that top one? Boom, you got a point. The displacement. So they want to know, hey, where does that snail end up? So I'm going to integrate how its velocity to get up its final position. What if it said, what is the total distance the snail traveled? Total distance, boom, boom. Okay, total distance, we're going to give that snail credit for all of its positive velocities and negative velocities. By asking what its displacement is it's going to take into account when it goes to the right and to the left or positive and negative velocities because it just wants to know where it ends up. What's the displacement? Cool, cool, cool? All right. You guys, that's 3 points. You get those 3 points. 1 point here, 2 points here. You're going to get 1 for this setup and 1 for this answer. So you do need to write this integral. If you only wrote the answer here, you're only going to get 1 of the 2 points. Okay, so again, when you type it in your calculator, write it on your page. We've got a 3 by just looking at parts A and B.
With you put like the integral of V of T.
Perfect. Yep, he's saying, yeah, let's go ahead and just do integral of V of T. You can leave off the DT. They anticipate you doing that. That is totally fine, bud. 76.043. Gucci, next page. How do we find, ooh. Didn't we find that the snail went 76.043? I don't know what kind of units we're talking about. Inches. So we're still talking about my snail. At what time is the snail's instantaneous velocity equal to its average velocity? They're asking, hey, can we think about the difference of those 2 vocab words? That instantaneous velocity is what calculus is all about. It's that derivative. That derivative gets you that velocity at that point in time. So it says, at what time is its instantaneous velocity equal to its average velocity? When we're asking average velocity, that's like average test score. How do we get our average test score? If I gave you 5 tests, add up with integrals, that's an S for summation, add up all the test scores or add up all the velocities and then divide by the interval or how many tests you have, right? What do you think your interval would be here? Yeah, so what do you think we should divide by? 15. So 15 minus 0 is going to be divide by 15. My interval will always match my bounds. And how am I going to find the average velocity? Where are my velocities? Go back to parts A and B. Did they give us any velocity? Yeah, good. Yeah, they said that snail's velocity is v of t. So what we can do is say, I need to add up the velocities. That's going to get me my average velocity. Let's just start with that. Yeah. Exactly. So let's think about that, because you're exactly right. If we just look at the top of this, Baxter, that's going to get his displacement, right? Or that distance traveled. And what is, they're asking for the average velocity. Do you agree distance equals rate times time? So when we take distance, or his displacement, divided by time, we're going to get his rate, or his average velocity. Great thinking. So good. So good. Distance over time will get me velocity, or rate. So could you guys go get me snail's average velocity? Did you get, I did not get the right thing on my calculator.
5.069.
Oh, is that what you got? Oh, perfect. Okay, I was looking at my final answer. Excellent. 5.069, or you could say 5.07, because that 5 would bounce that up. That's my average velocity. And now it's saying, hey, at what time is its instantaneous velocity equal to its average velocity? We get a calculator. Now, let's go ahead. I would go to our y equals screen, because they want an x value. They want an x value where the snail's instantaneous velocity is equal to his average velocity. So do you agree our average velocity is 5.069? So I'm going to make that my first function. And I want to go see where it's going to equal its instantaneous velocity. And what did they give us? They said the snail's velocity is given. So I'm going to go see what his velocity, I got to get my velocity function. My velocity function was 1.4 natural log 1 plus x squared. Boop. Now, what I've just done is I have set his velocity, the velocity function that they gave us, which is this red function, and I'm going to draw it for my people at home. The graph looks like this, that we've got his velocity here, and then the average value is here. Velocity and average value. And it says at what t are they going to be equal to one another? Exactly, because we don't want negative time, right? So what would we do on our calculator? Second, trace, intersect. We want to get that option 5. Bless you. And I'm going to go all the way to the right. Do you have allergies? They're so not fun. I feel like I go into sneezing fits. Y'all, I got what value? This is why I thought my, I'm going to say this equals his velocity at t equals, what would you say your t was? What's that intersection? 6.03? 030? Now, are we comfortable with this? Talk to me. They're asking for an x value, a t, whereas instantaneous velocity, and they gave us this velocity, so we graphed his velocity, is equal to his average velocity. But again, this is separating the 4s from the 5s now.
If you didn't think to do that, could you like set the function equal to this point everyone and just like solve? Because that's what I did.
Say that again, set the function equal to...
To the 5.0.
Oh, absolutely. And how did you do that? Solve it by hand or using your calculator?
I just did it.
Heck yeah. Hold
Well,
on.
I mean, I like
Good point. So Tully said, hey, wait, why didn't we do the derivative of v of t? To your point, the derivative of v of t would be acceleration, right? Since they gave us velocity, v prime would have been its acceleration. So they really already gave us the velocity. They gave us that derivative, if you will. Yeah, great question. Great question. Okay, this is where we're gonna get a little angry. This is to get a 5. You know, this is that final. But honestly, you don't. This is how many points is this part D? This one is ugly. Okay, it's 2 points. 2 points for this one. So we would have already had a 7. We're already at a 5 if you were to get all those other points. So you don't need this one to get a 5. This is just some extra bonus. Oh, this one's not fun. It says an ant arrives. Here comes baby ant. Starting position, his starting position at t equals 12 minutes and follows the snail's path. During the interval from 12 to 15 minutes, the ant travels at the same direction as the snail with a constant acceleration of 2 inches per minute per minute. The ant catches up to the snail at t equals 15 minutes. Wow, the ant's velocity at t equals 12 is b inches per minute. Find the value of b. Okay. Do you want some time to just kind of talk with people around you, try to muscle through a little bit? Couple minutes. This is one where you're like, I don't even know where to begin. That's fine that we can go through this together too. Here's why I had to think about this. I heard Tully, you say something. The ant's acceleration was how much? Was 2, right? And if we integrate acceleration, what do we get? Velocity. So could we integrate his acceleration to get his velocity with respect to time? Again, they're using x's as t's. Antiderivative of his 2. Antiderivative 2 with respect to t. 2t plus c. Whew. Again, this is an insane part of this question. Okay, so this right there, will they give us a point for that if we were to say that? Yes, this right here is 1 point. No, that's a good question. So it just says this is going to be his velocity at any point in time, right? Now, it says it's asking, what they gave us was during the interval of 12 to 15 minutes, the ant travels in the same direction with that acceleration. So what we can do, you're right, this is a velocity at any time. Let's go throw in our bounds from 12 to 15 to find out exactly how far he went. So, oh, no. Hold on. What did I do wrong? If he caught up to him, what do we need to take even further? If we've got his velocity, we got to make sure that he went the same distance, don't we? If he caught up to him, he went the same distance. He just started later. So, how I would say this is we need to integrate his velocity. So this is his velocity. We need to integrate his velocity to get that position or that distance traveled. So if I integrate 2t plus c, what's that going to turn into? T squared plus c is a constant. C, and then our x's are t's in this case. You okay with that? And then we've got plus our constant. Now, what are my bounds going to be if, again, we know it only took him 3 minutes to catch up? To your point now, Brode, let's go plug in our bounds.
What happened to the 2?
That's a great question. Which 2?
Like,
right here?
when we went from the integral, just like the bottom one.
This one here?
Yeah.
What happened to this 2?
Yeah.
Good call. Antiderivative of 2t is going to be add 1 to my exponent and then divide by my new exponent, and my 2's canceled. Great question, Tull. Okay, this is a hard part. We're going to be angry on this, but it's okay. If I were to evaluate this from 12 to 15, we're going to get upper minus lower. Again, these are t's. 15 squared would be, and you have a calculator on this if you need it. Anyone know what 15 squared is? 225 plus 15C or 15T? C, good. And then I'd have a constant. I did upper, and then what are we going to do? Minus parentheses, lower. 12 squared? 144 plus 12C plus C. Does that simplify? 225 minus 144? 81 plus how many C's? 3 C's. This is his position, y'all. This is his position. So, from 12 to 15, Mylanta. Now it says the ant, this is all about my ant. This is my ant's position. The ant's velocity at time t equals 12 is b inches per minute. And again, he caught up to my snail. Have we found out in any problem how far my snail went? From part B, we found out that my snail went 76.043 inches. And they're asking, we're saying that my ant caught up to it. So we've got to go solve for C. When did that ant catch up? When did his position equal 76.043? So go solve for C using your graphing calculator. Did you get negative 1.652?
Do they take into fact, like, say you get B wrong, but you stay consistent?
You'll get 100% on this. Yep. Yep. So you wouldn't have gotten B's final point, right? But you would get full points for this if you did it accurately with the wrong number. Good call, Bird. Okay, people, so let's back it up. Let's think about what the heck we just found. We found his velocity, the ant's velocity, to be this. We found my C has to be negative 1.652 for that ant and snail to have gone the same distance. So can this take my C's spot here? Certainly. Because it's asking the ant's velocity at time t equals 12 is what? This is my ant's velocity. We solve for C. We can go plug that in here. And it says when t is 12. So let's go find my velocity if t is 12 and my C is negative 1.652. Thank goodness for calculators. Go ahead and see what your final answer is. What'd y'all get? 22.348. Now, do not let this part discourage you. Do not let this part discourage you. You have got, this is one part of a lot of parts, so don't let it discourage you. Part D was insane though, okay? And again, it's not all or nothing. Do you guys want to get up and stretch? It's been 45 minutes. Okay, you guys, on this first one, it just says, hey, here's G. F is given here. So I'm like, okay, here's F. It said this function has two linear pieces, so that's a line, and that's a line, and then a semicircle. Whoop! They want us to find F of 7. I'm going to give you guys a little bit of time. I want you to try to find F of 7 and F prime of 7.
How do you get G?
Yeah, so F of 7 is 3 times 7, or you could just write 21. 0 to 7 of G of T. Look what this graph is, bro.
Yeah, but like, how do you, would it just be 3?
Yeah, good question. What does this mean? What do they want here?
But you have to plug in
If that's G and I've got the integral, they just want the area. from, oh, I'm sorry, 0. I went too far. From 0 to 7, are you saying how do we even find that? I got you, okay. So they want the area from 0 to 7. So I want to find the area of that half circle and negate it, and the area of that rectangle and add it.
Would it just be half of that or
Um,
because it's 7?
oh yeah, oh my gosh, great observation. He's saying stop at 7, Lombo. Boop, 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 boop.
So it doesn't matter if they're not connected.
Good call. It does not matter that it's not connected. So we've got 21, and go try to find the area of that half circle. Nothing needs to be simplified. I would leave my answer here in black. I would not simplify. Say, AP, that's up to you to simplify. If you did, 24 plus 9 pi over 2, is it simplified? We can get that. Oh, snap. Did I do something wrong? What'd I do? I didn't negate my circle. So is it plus 9 pi over 2? No, Lombo. Sheesh. Minus 9 pi over 2. Minus 9 pi over 2. Whew. And then, okay, we okay with that one? Tay, talk to me.
Wait, how do you find the area of a circle?
Yep, good call. Area of a circle is pi r squared. So I did pi, and my radius here was 3. So I just said, how far to go from the middle?
Okay.
Or you could count the whole diameter and cut it in half. So my radius is 3.
6, that's why I was confused.
Gotcha, yep. And then you guys, if they want f prime, always start with f prime of x. What would f prime look like? And I'm going to give you guys a second. Tay, you had a premonition. I got 6 here. You just said 6 up here. I got 6. So you guys okay with that? Derivative of 3x got me a 3. Derivative of an integral cancels out. And I was left with g of x. They want f prime of 7, so it's g of 7. The value of the function when x was 7 was 3. Get you down with that? Okay, we just got 2 points. We're at a 22%. We want to get to a 35%. Okay. Now it says, find the value of x where we have a maximum. Justify. So they do want some words on this one. What makes maximums?
When after like the first derivative like that was
Yep.
positive.
Good. Could f, because this is on a closed interval, could my maximum just be where f prime was positive? If my function then ends, right? Like if this is my function, we would have a maximum here in this picture. But again, if my function ends, we could have just a maximum here. But we do need to take a peek at our endpoints because my function could be like this. So we'd have a maximum here and a maximum there. Relative, absolute. Okay, so it says, where do we have a maximum? You just said where f prime, and to your point, bud, they're asking for f. So we're looking where f prime is positive. Can we go find f prime? Have we done that yet? We already found f prime right here, y'all. F prime, so we're looking where 3 plus g of x is positive. What do we always have to set that equal to? Yeah, let's go set that equal to 0. Now, where it's positive. If it did, okay. Where would 3 plus g of x, and again, this is g, equal 0? What x value is what they're looking for? Any ideas on how we could do that?
Yeah, can we just look at the graph?
Yeah, we have to look at the graph. I love it. So what are you thinking? So do you guys agree that we want my f prime to be positive? Is my f prime positive that whole time? From -4 to 3. 3 plus g of x is my f prime, right? F prime is 3 plus g of x. They're saying that the maximum happens at x is 3. The maximum must occur when x is 3. It says because f prime is greater than 0 from -4 to 3. Do we agree with that? Do we know that? Here's my f. Do we agree f prime is greater than 0 the entire interval? Right. But if I were to find the area of this quarter circle, like if we went when x is 3, at x is 3 here, if I found the area of that quarter circle would be pi r squared over 4, right? That'd be 9 pi over 4. And the area of this triangle is not 9 pi over 4 to like negate it, to get it to 0. Excellent. The lowest value of g, correct us if we're wrong, is -3. So 3 plus -3 is never going to be negative. It's going to be 0 or positive. Thank you, Abby. The lowest value. So it says because f prime is greater than 0, you're right. The lowest value of g is -3, so it's never going to be negative. Whew! So if f prime is always positive, because it's not negative, if it's non-decreasing or always positive over the entire interval, the maximum must occur when x is 3. How do we feel about that part? At the right.
Why is that the max?
I agree. When x is 3.
Oh, because the slope, which is f prime, that's when it like decreases the most. So that would be very top because it's always greater than 0. So it like it's constantly increasing and then it gets to 0. So that would be its top value.
Yep. Okay, I like it. But if this is f,
Yeah.
and then this is f prime, 3 plus g,
When we're doing
Bless you.
f prime, it's going to be getting closer to 0, which means that would be the top of the.
Yeah. Wow. Yep. You're so right. Holy cow. So this is their rationale here. They're going to give us 2 points that I would imagine, again, they already gave us a point for this in a previous problem. So they're looking for this entire explanation. My gosh, that's a lot to explain. But to your point, that f prime is always going to be greater than or equal to 0 because, like Abby said, 3 plus these g values, it's always going to be positive because 3 plus -3 is going to go 0 and only greater from there. Wow.
But isn't it getting bigger the entire time?
Mm-hmm.
That's why
Because we're going to hit that maximum here because think about, we've got our 3 plus -2, 3 plus -3, but then we're going to start going back down, right? So we're going to hit our highest value.
Well, why would you be going back down? I thought it would be going back up.
3 plus,
Because it'd be 3 plus -2 is -1, and then you get back to 3 plus 0 is greater than 0.
yeah. Here we've got a little limit notation. So now it says for each, the limit as x approaches 0 from the negative side of g prime and the limit as x approaches 0 from the positive side of g prime, find the value or state that it doesn't exist. So where the heck is our g function? G is just our graph. Okay, but we're looking at g prime. So I'm going to go snap a picture of our graph, actually. It's going to be a little funky. They want this limit as x approaches 0 from the negative side of g prime. So as we approach 0 from the negative side of g prime. This is g. What do we have to think of when I'm doing g prime from a graph? The slope. As I'm approaching 0 from that negative side, what do you think that slope is going to be? Negative. It says they want us to finally actually get it. The limit as x approaches 0 from the negative side of g prime would be what? Yes, negative 1/2. The slope, the rise over a run, down 1/2, down 1/2. That's a point. This next part is a little ornery. They want as x approaches 0 from the positive side of g prime. I think that you'll be all right with this, actually. You guys, what would you say the slope is here as we're approaching 0 from the right side? Undefined, because it's approaching that vertical line. Therefore, find the value. Undefined is not a value, or state that it doesn't exist. From the right-hand side, that limit doesn't exist. Because again, don't forget, limits are what happens as we approach that point. Those slope values are going vertical, and a vertical line does not have a slope. It's undefined. Okay. Let's go try D. This is that. I'm not going to say the word because I don't want to give you a hint yet. How might you start D? This looks insane. We always start it the same way, a limit. Any ideas? Always just plug in first. Go plug in that value, see what you get. F of -2. Yes, we're going to have to because we're going to get a 0 on top. How do I get f of -2, you guys? The f of x function was this. 3 times x plus 0 to -2 g of t. To find f of -2, I'm just plugging in a -2 into my f function. So that's going to get me a -6. How am I going to find this? The area from 0 to -2 and then negate it. Oh, well, they didn't give us, since this is G, we got to go to that graph, right? So I'm going to go back up to my graph here. Boop. Can I find the area from 0 to -2? They want this area. Boop, 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 boop. I'm going to put that in this. They want this area. But they have our bounds funky, don't they? Shouldn't that be flipped? So I'm going to negate that area because my bounds should be flipped. So from -2 to 0, what would be the area of that triangle? 1/2, what times what? 2 times 1. So what would be this f of -2? -6 minus 1 is going to get me -7. So we have 0 over 0 when I simplified that. Miss Tolley said, don't we got to do that L'Hopital's? If you get 0 over 0 or infinity over infinity. L'Hopital's says do what to each of these? Derivative of the top and then the derivative of the bottom. We do not have to do quotient rule. Derivative of f. F prime. Derivative of 7. Good. Ooh, derivative of e to the anything is e to the anything times 3. Derivative of -1 is 0. You guys with L'Hopital's, you go plug that back in. And we hope that we get a value over something not 0 over 0 again. But we might, and then we'll do L'Hopital's again. We need f prime of -2. F prime of -2. And on previous pages, we said f prime of x was 3 plus g. So f prime of negative 2 would be 3 plus g of negative 2. G of negative 2 is 1. Awesome. So the top would be 4. Is that right? If x is negative 2 on the bottom, we'd have e to the 0, which is 1. 1 times 3 is 3, and my answer is 4/3. Whew. Okay. Okay. We just zipped through that minus part B. B is 8. I'm mad at B. Okay. Yep. Okay, y'all. Whew. Find the area of R. Area. Upper minus lower. All day, every day. Here's F. R is the shaded region. Bounded by F, and the horizontal line Y is 3. That there's what? Not one upper? Is that what you're saying?
Yeah, like, don't you have, isn't.
So with this one, I feel good about keeping it with respect to x because my upper is that function which they gave us.
Never mind, I thought those were different.
Oh, gotcha. Okay, you guys, I'm going to give you a sec. Oh, this says no. Oh my gosh, this is non-calculator. Oh, y'all are going to be so angry at this. Go do your setup. Your setup's going to get you 2 points. We're going to have to find those bounds, right? Without a calculator. When does 6 over 1 plus x squared, what would we set that equal to find those bounds? Yeah, when are they going to intersect? Found my bounds. And how would your setup statement be for this? What would be that integral? -1 to 1. Upper minus lower. I'm going to actually write it out because we have to analyze this without a calculator. Oh, gosh. Wow. Y'all, you're going to be mad. On your big ideas sheet, there's an antiderivative of one that is not used frequently. Hoo-wee! I want you to think we could picture this as the integral of -1 to 1 of 6 times 1 over x squared. 1 over 1 plus x squared. Minus, and then again, an integral of -1 to 1 of 3. I could kind of separate this. The reason I'm doing this is, does anyone remember which inverse trig function this is the derivative of? It's my favorite because there's no square roots and no negatives. Yes. Oh my gosh. So the antiderivative of inverse tangent, this derivative is 6 times 1 over 1 plus x squared. That is on our derivative rules sheet. I could take a picture of it right now. They might have one question on the whole test. On this one, it happened to be part of a free response. Gross. That is part of our derivative rules. Boom. Right there. Gross. So that is the antiderivative. And again, we're going to have to say from -1 to 1. Yeah, don't forget about the 3. What's the antiderivative of 3? So to your point, I can keep those bounds separate because they're both going to be from -1 to 1. Antiderivative of 3 minus 3x. All of that from -1 to 1. Now, you guys, yeah, they'll be fine with inverse tan because there's no variable. You can plug in those bounds, and you do not have to solve it. We will just remind you how to find those inverse tans, but inverse tan of 1 minus 3, that's upper, minus my lower, 6 inverse tan of negative 1 plus 3. I would end right there. Did I do something wrong, Brad?
Wait, do we use the 6 in both of them, or I thought it was like we had to keep them out?
Good call. That 6 would only go with my inverse tan one. And again, putting, it's going to stick with my inverse tan because, again, that right there is his antiderivative. You okay with that?
Yeah.
Now, anyone think on the unit circle, where is the tangent 1? Anyone have reminders on that? What? No, where is the tangent? At what radian? Pi over 4. At pi over 4. So at pi over 4, boop. This is the point root 2 over 2. Root 2 over 2 at pi over 4. Therefore, the tangent, the y over x, is 1. But you guys don't simplify it. We can end it right there.
Wait, it's tangent of 1, right?
Where is the tangent 1? The tangent is 1. The y over the x is 1 at pi over 4. When it's inverse, they want the angle. So you guys just leave it right there. Do not simplify. I can't believe they did inverse tangent. That's so ridiculous. Okay, now we're going back to these areas and volumes that we were practicing in the last section. Part B says, hey, write but do not evaluate an integral. Cool, I know I need an integral. Of the volume. Volume is just area of that cross section where we're rotated around the horizontal line, y equals 7. When I've got to revolve this around the horizontal line, y equals 7. Funky. So I guess if I were you and I didn't have this nice little gadget, I'd say, all right, this is what we started with. And if I had to go around the line, y equals 7, I'd say here's 7. And I'm going to reflect it. And when I revolve that around, I'm going to have an entire circle and an inner circle. Whew. Volume is area of that cross section. You guys define the area of that entire circle. All day, every day, you're going to do upper minus lower. But always go from the picture they gave you. Don't go upper from like what we added. Go from the picture that they gave us. Meaning they told us, here's my horizontal line, and here's the part of the graph they gave us. So what would be my upper if I'm only focusing on this part? What would be my upper function? I heard it. 7. 7 is going to be my upper function. And when I do that, that 7 distance is going to get me this yellow distance. This is 7. What do we want to subtract from that to get the entire circle radius? Say that again. Yeah, that 3. Yellow minus red, 7 minus 3 is going to leave me with this green entire radius. So 7 minus 3 is going to get me the radius of my entire circle. How do I find the area of a circle? Pi radius squared. That's going to get me the area of my entire circle. But then I need to take out the area of this red circle. And this red circle, what would his upper be? 7. I'm going to take out the 7 minus his lower, f of x, this function here. This function here. And if I did that, if I did if I did this black 7 minus this green f of x, that's going to leave me with this yellow radius. 7 minus f of x, you just said, is going to get me the little circle's radius. So I'm going to do the entire circle pi r squared minus the little circle pi r squared. They said just set it up and don't evaluate. This kind of looks like the Colorado State logo. I know I got the yellow, orange, and red, and blue going on. Okay. Oh gosh, why am I forgetting my bounds? Yes, we certainly do need my bounds. And did we already decide that those were from -1 to 1? Yes, perfect. Okay, here's how we're getting from separating the, I don't know, this is really separating the 5s from the 5s, honestly. Sounds a little silly, but. So it says, let H be the vertical distance. I'm just trying to get my picture back. Let H be the vertical distance between a point on the function, and the horizontal line y is 3. Find the rate of change of H with respect to x, then at 2. Okay, let's try to interpret what the heck they're saying here. Let H be a vertical distance between a point, I'm going to throw this point here in red, between a point on the function and the horizontal line 3. They want to know, this would be H then in this picture. This little red is that vertical distance between a point of the function and 3. Can anyone help me find just how would we figure out what that is? Upper minus lower. We love upper minus lower. So do you agree f of x minus 3 is always going to be that vertical distance? Oh, geez. Hold on. Let h of x be the vertical distance between a point and the horizontal line 3. I have 3 minus f of x written. Why would I have flipped that? F of x minus 3 is that. Why would I have flipped that? Hold on. Did they have it flipped? 4, they have 3 minus f of x. Why would we do 3?
To do with the rate of change, or is that?
Yeah, we are going to take a derivative. I guess I was only looking at this region here, but could we say, here's a point? Like, why would that change it? Let h be the vertical distance between a point and the horizontal line. So,
It's at x equals 2, so it would be.
oh, at x is 2. Thank you, Toli. Oh my gosh. Okay, when x is 2. When x is 2, do you agree? My upper really is that 3. Shoot. My upper is 3. Vroom. If I did 3 minus my lower, which is my function, where is that actually going to find? That's going to be the vertical distance. I see that is going to be this black distance, right? Okay, this blue. Look at if we did 3. 3 is going to find this distance minus f is the green distance. That would leave me with this distance, this red distance between that point and the line y equals 3 at 2. Okay, okay. Now it says find the rate of change of h. So we just said this is going to be h of x. Let's go find that rate of change. Do we know what f of x is? Did they give that to us? They gave us f of x to be 6 over 1 plus x squared. You guys, they want the rate of change. They want h prime. All right, let's go find h prime. What would the derivative of 3 be? Good. How do we find the derivative of negative 6 divided by 1 plus x squared? Loady high, loady high. So I'm going to just throw that negative with the 6. I'm just going to go say like plus negative, so I know my high is negative 6. Okay, low, d high. Good. Minus high, d low. All over, low, low. They said, hey, go find that rate of change when x is 2. See you at the end. And when I say the end, just plug it in and don't simplify it, people. You could leave it right here, or you would have gotten 24 over 25 if you simplified it. But shoot, people.
Would it be negative?
I got positive. Am I crazy?
Well, it is the low, and then minus
Yep.
6 2x, right?
Yep, so, but don't forget, it's low D high minus the high, so minus my -6 would turn into +6. Good questions, though. Okay, we're getting there, peeps. Was that the end of it? End of 4? Whoo, okay. Okay. During a chemical reaction, we've got amount of substance presents that comes during a chemical reaction. F of T models the amount of substance present in grams at T seconds. At the start of the reaction, when T is 0, there are 10 grams. I would underline that. At the start, there are 10 grams. We're going to need that at some point. The function y of t equals f of t satisfies that differential equation. And we got dy dt. Use the tangent line at t equals 0 to approximate something. Let's go first write the equation of that tangent line. Equation of a tangent line. Do we have a point? Exactly. At t equals 0, there are 10 grams. There's a point. Did they give us a slope? Yeah. Let's go plug it in. Now, which one is x and which one's y? Yeah, the t is 0, right? And the y, that's going to be my y. The t is really my 0. So my y is my 10. So I'm going to say, all right, my slope there, dy dt, is negative 0.02 times my y squared. If you guys don't want to simplify that, you don't have to. But how?
Not like writing the y minus y equals.
Oh, yeah, I'm just getting my slope to plug into that point slope form. Good call. So you can just totally leave this as your slope, you guys. Is that negative 0.02 times 100? And that would just be, what is negative 2/100 of a times 100? That would get us -2. But you guys, you don't have to simplify it. You can leave this as your dy dt. So if we were to write that equation, Brode, what would that be? Y minus 10 equals my slope. You don't have to simplify that. We can just write it like that. Boom. Times, instead of x, we should write a t here. T minus 0, or you could just write t. They said use that to approximate the amount of substance remaining when t is 2. So I'm just going to go plug in a t is 2. And I'm going to move things away from the y. Yeah, Tay-Tay.
Would you like get a point off if you were to write like x minus 0?
I know. I sure hope not, but you might.
Okay.
Because you might. So just kind of mind the variables. Try to note how they've written them, because that's annoying. Guys, we could end it right there. If we did get an answer, that'd be -2 times 2 would be -4 plus 10. My answer is 6, but you don't need it. We can end it right here. Just make sure to get that y by itself. Okay. This next part I think is really hard. Part B. It says using the differential equation, they gave us this. Determine whether the graph of f could resemble the following graph. Here, this is f's derivative. Could this be a graph of f? Whew. Could this be a graph of the function if that's its derivative? Question. No matter what y value we put in here, what is my derivative always going to be? Negative. So do we agree dy dt will always be negative? Because that negative 0.02, no matter what we plug in for y, my slope will always be negative. I think that's just a hard, like, how are we supposed to even know? Look at that. Because look what it says. It says, using the differential equation, okay, so using that, determine whether this could be a graph of f. Could this function have this derivative? No. Why? Yeah, my function is decreasing there, but then it's increasing. My f prime would be positive here. F prime is positive here. So my fancy writing, I said, if dy dt was less than 0, the function is always decreasing. This graph is not always decreasing, so it does not resemble the equation. Let's say that one more time. Let's answer the question it says. Using the differential equation, so we already have this written, dy dt will always be negative. Therefore, you could do this little boop, boop, boop. Therefore, little triangle, dots. This graph is not resembling f because part of this graph is, how could we say that? What word could we use there to show what's going on here? Yeah, or we would just say because f prime is positive here, or my function is increasing because this graph is increasing. We got this. We got this. Now it says, this is the Big Mac Daddy. Find an expression for solving the equation with the initial condition. What do you think we ought to do here? They want the y equals, and they gave us the derivative. Say that again. Yes, separate the variables. We're doing that thing. We've got to separate those variables. Do you guys want a second to try this? I think y'all can do this. I'm going to write out the points. 1, separate the variables. 2, constant of integration. Well, first we're going to do antiderivatives. When you separate your variables, you guys, we want to get y by itself in the end, so leave the negative 0.02 on the right side. Just divide out that y squared. I personally had to rewrite my y squared as y to the negative 2 to help me take that antiderivative. Antiderivative of y to the negative second, I added 1 to my exponent and I divided by my new exponent. And then I rewrote it just to make my life a little easier. I'm going to use my initial condition. T is 0, y is 10. Negative 1/10 equals c then. I'm going to plug it back in to solve for y. I did not distribute my y to everything because I want to just keep it lumped on that right side so I can easily divide out that quantity, negative 0.02t minus 1/10. So my final answer is ugly, negative 1 over negative 0.02t minus 1/10. We're almost there. It's from the fives. Determine whether the amount of the substance is changing at an increasing or decreasing rate. The amount of the substance. So they told us that they gave us, how did they explain what dy dt was in part A? They said during the chemical reaction, f of t is the amount of substance present at the start of the reaction. The function satisfies the differential equation of dy dt. So determine whether the amount of substance is changing at an increasing or decreasing rate. Well, we've got the rate that substance dy dt they gave us was negative 0.02 y squared. Y'all, is that rate increasing or decreasing? Say that again. Oh, you know it.
I don't know.
Oh, I gotcha. Well, since they're asking for another rate, I want us to go take that second derivative. Okay? So it says determine whether the amount of substance is changing at an increasing or decreasing rate. What's going on with that rate? If that second derivative is going to be positive, then it'll be increasing. If that second derivative is negative. So let's go find that second derivative. That d squared y over dt squared. This is ornery. We're deriving with respect to time. Again, this is separating a 5 from a 5. Don't lose sleep over this part D. What would that second derivative be? Negative 0.04y times the derivative of y with respect to time. dy dt. This is one of those related rate questions. Let me say what we just did one more time. We took the derivative of this function that has a y, and we're taking derivatives with respect to time. So we took the derivative of the outer, we left the inner, times the derivative of the inner. This is separating a 5 from a 5. Do not let this discourage you. Could we replace all of this right here for dy dt? If I put that right back in, I'd have negative 0.04 times my y times my negative 0.02 y squared. And this is non-calculator. Whew. Okay. I don't care what that value is going to be. Would it be positive or negative? Yeah, we'd have a negative times that negative, though, to get a positive, right?
Wasn't it squared?
This one?
Yeah.
But only the y is squared. That's a good question, bro. Only the y is squared, not that quantity. So are you cool with saying 0.04y times 0.02 y squared? You could write it like that, or we could say 4 times 2 is 8. That's going to get me 0.00, what do I have? 0.008 y cubed. Okay. Now, it says determine whether that is going to be positive or negative. And again, let's think about what y is. Is my y ever going to be negative? My y is that amount of substance. Am I ever going to have a negative amount of substance? So no matter what I plug in here, my y is always going to be positive. Therefore, this value will always be positive. So would we say that this rate is increasing or decreasing? Yeah, I'm going to say an increasing rate because 0.008 y cubed is greater than 0, or you could say would always be positive. Okay, whew. Last one. Last one. Consider this curve. Show that the derivative is that. I love these ones. They're telling us what it needs to be. We just have to go prove it. We got to go prove it. dy dx. Go try to take this derivative and see if you can get dy dx to be this. To be this. Thanks, Tully. So go take this derivative. dy dx.
What?
So if I take the derivative of this entire equation, how would I take the derivative? Maybe we start on the right side just to clarify things a little bit. I'm going to say, what's the derivative of this right side? What's the derivative of 3? 0. The derivative of cosine? Careful. Negative sine of y times the derivative of my angle. dy dx, and I know that because of what they put here. They want it with respect to x. That's the right side. How would I take the derivative of this left side? We could totally distribute. I like that. She's saying first I'd just have 2x minus 2y. I love that. What's the derivative of 2x with respect to x? 2. dx dx, don't need it. Minus the derivative of 2y with respect to x. 2 dy dx. You guys, they want dy dx equals this. Go move your dy dx's to the same side and see if we can factor them out and get it to equal that. Where'd I lose you guys?
I tried to start it different, I think.
Okay. Ooh. Is there a point that the curve has a slope of 1? Okay, the slope of 1. Can we go see if this is ever going to equal 1? Right, because that's my slope. Let's go see if 2 over 2 minus the sine of y is ever going to equal 1. How would you start trying to get y by itself? Yeah, let's multiply by that denominator. And this is some good old algebra. Sine of y. Okay, yeah. So if we subtract that 2 over, we'd have negative sine of y equals 0, right? If I subtracted my 2. Could I just divide out that negative and say, all right, when does the sine equal 0? At what angle is the y coordinate 0? At 0, right? On the unit circle, over here, this point is 1, 0. That is 0 radians. The y is 0 there. So if my y was 0, at y equals 0, y being my angle here. Now it says, there is a point P where the slope is 1. We said, yes, the y coordinate is going to be 0. How can I go find that x coordinate? Yeah, it says it is on the curve. You guys, here is the curve that they gave us way up here. Here is the curve. So we're going to say if y was 0 here, we'd have 2 times x minus 0 equals 3 plus the cosine at 0. That's me plugging in my y is 0 up here. I would get 2x equals 3 plus, anyone remember the cosine of 0? Yeah, the x value at that coordinate is 1. And it says find the coordinates of point P. X is 2, my y is 0. There's my point P. Okay, y'all, we're almost there. We're almost there. Woo, last 2. It says determine the concavity. What do we know? What do we need for concavity? F double prime, that second derivative. And have we done that, or did we do a second derivative on a previous question? Or did we do it on this one? Not this one. Okay, shoot. Here's our original, y'all. Our original, my dy dx, was 2 over 2 minus the sine of y. Whoo! Here we go. Second derivative. That's the first one, right? That's nice. Go find that second derivative. What rule are you going to use? Yes. Low d high minus high d low all over low low. You've got to be careful. Right here? Oh, good question. Low d high minus high d low. That should just be a 0, shouldn't it? Thanks, Brode. Did we remember our dy dx? Low d high minus the high d low. The derivative of the lower is what we're going to mess up on. The derivative of 2 is 0, as Brody pointed out. The derivative of negative sine is negative cosine of the angle times the derivative of the angle. Woof. All over low, low. Now, you guys, what can I plug in for this dy dx? We say, well, shoot, this is dy dx. So I want us to plug that in and just kind of simplify some things. If I were to plug that in, I'd have a negative 2, negative cosine of y, times 2 over 2 minus the sine of y, all over low, low. Wow. Now they're asking, determine the concavity. You guys, from this, we need to know if my second derivative is negative or positive. Because if my second derivative is negative, it's concave down. If my second derivative is positive, it's concave up. Oh my gosh. Can we simplify this? Yes, we can, people. Yes, we can. Let's think about algebra. I'm going to put these things over 1. If I wanted to multiply this, just this numerator, negative 2 times my negative cosine, are you cool with saying we would have, if I multiplied a negative 2 times a negative cosine times a 2, are you cool with saying on the top it'd be a 4 cosine of y? You okay with that? Over my 2 minus sine. That's this numerator. Dividing by this thing is this, multiplying by its reciprocal. The reciprocal of this guy is going to be 1 over 2 minus the sine of y squared. So does that simplify? Sorry, I'm writing this up here now. 4 cosine of y over that 2 minus the sine of y to what power? Cubed. Now, look at what my y values are. My y values are going to go from negative pi over 2 to positive pi over 2 to be plugged in here. Yeah. How'd you know that, Brode? Huh? Well, let's think about on a unit circle. Where's my pi over 2? My pi over 2 is up here. Pi over 2. So these y values would be positive, and my negative pi over 2 is down here. These y values would be negative.
But it's all 1, so like the 2 would happen to be greater than the negative 1.
Exactly. You're saying my y values, I love it. At this point is 0, 1. This point is 0, negative 1. 2 minus anything, these y values are going to be as high as 1 and as low as negative 1. 2 minus any quantity is going to keep this quantity positive, isn't it? Oh, the cosine of these y values, the x coordinates over here are always positive. So, wow, we're going to say because my second derivative, dy squared over dx squared is always positive. Instead of writing is always positive, I'm going to just say it's greater than 0. We're going to say my function, the function is concave. Awesome. Whew. Getting that last point. That one on question 6, they would give you, if you were to take that second derivative, you're going to get 2 points. 2 points for taking that second derivative. But again, remembering that dy dx is hard. Okay, let's finish it. We got 4 minutes. Oh, mean value theorem to finish it up. It now says, f is a function defined implicitly, we've seen this before, that is continuous on this closed interval and differentiable on this open interval. These are necessary words. Continuous and differentiable are necessary for that mean value theorem to apply. Oh my gosh. Now it says, show that. This is insane. F of 2.1 minus f of 2 is going to be between, Siri, between 1/15 and 1/5. Hoo-wee. Okay. F of 2 minus f of, well, let's talk about what the heck this mean value theorem is. That mean value theorem, one more time, is saying, hey, if I've got this function on this closed interval, if I've got this, I'm going to say red function, this red function on this closed interval, and this function is not only continuous, yes, it's also differentiable. And the mean value theorem says, hey, there's going to be some other point that has the same slope as the average slope between those 2 points. Okay, so the mean value theorem worked out is saying, hey, f of b minus f of a all over b minus a, that's the average slope, is going to be the derivative at some point c. This question is so dumb. This question is so dumb, y'all. But we're going to get through it. You guys, if we know, if they want that f of 2.1 minus f of 2, if we were to find that average slope, on my answer, it says from the original question stem, we know that my slope is between 2/3 and 2. Is that what they said on the original question? Geez, oh man, if we go back to part 6A, I'm going to show you. On part 6A, it says 2/3 is less than or equal to dy dx is less than or equal to 2. It's saying this right here, that my slope is going to be between 2/3 and 2. This right here is finding slope, change in y over change in x. So we can say this is between 2/3 and 2. Oh my gosh. Now we want to just go simplify this, and I guarantee we get this 1/15th ditty going on. Let's see what we got. So what is 2.2 minus 2 going to get us down here? 0.1. 0.1 is the same as 1/10, right? They just said show that this is a true statement. So if this is being divided by 1/10, could I multiply each side by 1/10 to get rid of it from the denominator? Yes, I can. If we multiply everything by 1/10, I'd get 2/30. The 1/10s are going to cancel out here. F of 2.1 minus f of 2 is less than or equal to 2/10. Is that going to simplify to what they want? 1/15 f of 2.1 minus f of 2 is less than or equal to 1/5. That's disgusting. And again, you guys, that is to separate the 5s from the 5s. You do not need to even write anything here to get that 5. Do not get discouraged. So again, kudos to you for coming. Whew. That was a lot that I just jammed down your throat. Like Zoe said, go get the ones that we can do. If you leave things blank, you are still going to pass this test, I promise. Okay? I think it is worth taking a peek at your cheat sheet, if you will, just to go over some ideas before Monday. Just remember some derivative rules. I definitely think looking at your derivative rules is helpful. And other than that, you've worked the whole year for this, guys. Don't worry about it. Don't worry about it one bit. Okay? Get on out of here.